Okay, good afternoon, everybody. Hope you've had a good lunch. Welcome to Black Hat. Welcome to London for those of you that aren't natives. I'm Tim. I work at Cisco, and I've been looking at Active Directory and UNIX implementations thereof. Everyone always thinks Cisco is just a routers and switches company, but I think in this day and age we do all manner of things, and Active Directory obviously plays a part in some of those activities. So, by way of introduction, I'm going to do a quick TLDR on what the talk is and what the talk isn't, in case there's anybody that thinks, actually, this isn't for me. I'm going to run through who I am, and then I'm going to outline what the talk covers. So, as a TLDR, this is a work in progress. I've spent probably the best part of 9 months off and on looking at different aspects of this. I'm currently up to 3 vendors. There are probably more vendors I ought to be having a look at in due course. It's not LDAP, it's not Kerberos, it's not Active Directory per se. It is, however, how Unix estates integrate into Active Directory, the software that's used, and the bug classes that you might reasonably expect to find on such an estate. And it's really about what happens if your Unix boxes get compromised. Everybody always thinks that Active Directory gets compromised because somebody clicks on a link in an email, etc. Well, there are other ways to compromise an Active Directory, and Unix is one of them. Yeah, we put an awful lot of emphasis on those big boxes that sit in a data center, and we don't always realize that they have trust relationships that extend potentially far further than those systems themselves. So, who I am and why I think I'm qualified to talk about this. So, I'm Tim. I've got a background in telecoms and financial services, and I've done the best part of 20 years in various different security roles. Operational security first and foremost, some time as a penetration tester, and at the moment I'm doing quite a lot of security engineering. And I like to find bugs. I like to find bugs that scale. It's no good finding that one bug in that one application. What I want to do is find bugs that open up doorways all over a network. So the plan for the talk today is I'm going to run through the background, a little bit of the theory of Active Directory for those of you that perhaps haven't looked at it at all. I'm going to run through some of the attack chains that I've been working on, what they look like in terms of practical attacks, the mitigations, the response, because I think that's a key part. The vendors in this particular instance have been fantastic. Couldn't have asked to work with a better bunch of responders. And then finally some conclusions, and if you're dead interested, at the end of it there is some bonus material which obviously will be in the slides that go out publicly after this talk is concluded. So the background. Over the last 15 years I've noticed a huge uptick in the amount of AD that is appearing on networks from a Unix standpoint. When I started 20 years ago at a bank, we were using Tivoli. We were pushing out users to essentially password files. We were hoping that those files synced, and when they didn't, we were going to try to fix those problems. These days, a lot of systems are AD connected, and so what's actually happening is people are coming in with their normal corporate ID, they're logging onto their Windows machine, they're doing all of their Windows day-to-day. When they drop across onto the Unix infrastructure that they possibly manage as part of their job, they just log in with the same set of credentials. And the reason that works is because of Active Directory. So there's a compelling argument that Active Directory makes life easy. But the problem is that with that, you have 2 responsible parties, neither of whom necessarily understand the capabilities, the threat landscape of their opposing party. You have your enterprise admins. So your enterprise admins are responsible for the Active Directory forest. They're the guys that ultimately put users onto Active Directory domains. They're the guys that probably set the policies, etc. What they don't do is have a real hard think about what happens when you deploy Active Directory onto Unix and what policies need to be applied there. They don't necessarily have a good grasp of what the limitations of Active Directory on Unix are from a group policy perspective. So what you end up in is a situation where you might have, say for example, a SAP infrastructure. SAP infrastructure has 4 or 5 different environments, ranging from dev through to production through to DR. You have maybe 10, 15 boxes in each of those environments, and The view from the business is that the development environment probably not that important. It's where they do their development work. It doesn't contain customer data. It doesn't contain business data, so that it doesn't get well protected. But if that's joined to your Active Directory estate, not only do you have the ability, if you compromise that system, to go after other parts of the SAP infrastructure, you also have the ability to go after other bits of the enterprise infrastructure as a whole. So the trust relationships are really quite interesting, and they're not necessarily hugely well considered. So, as a case study, this was patient zero, if you will. So we have a customer that uses Vintella. And if you look at CVE details as a benchmark of what the maturity of the software is, there's no bugs, which means presumably it's great. There's no concerns from an administrative perspective. You can just go and deploy that wherever you like. But we see it too in places like critical national infrastructure. We see it across the financial services space. We see it in lots of different places. Time and time again, we're running into Active Directory joined UNIX systems. So what does this actually mean? We're expected to tell the customer when they've got it wrong. Interestingly, turns out Cisco use Active Directory on Unix too. So when I started this conversation and started speaking to our internal teams about, I need to go and report this, they came back and said, actually, we've got that software too. So this is why it's a work in progress, is because I've been patiently working through our internal stakeholders as well as the software vendors, etc. But hopefully the research is going to be good in the long run for them, for you guys in this room, for the industry as a whole, because at least we'll start to talk about this problem and what it looks like. So the theory, Active Directory on Unix doesn't look a whole lot different from Active Directory on Windows. If you imagine SSSD is your LSAS, if you imagine the SSD talks to Linux via PAM, well, that's similar to MSGNA. Just because you're taking a photo of it, that's a Red Hat slide. So that's Red Hat's description of what SSSD looks like. But essentially, in between that, you have Kerberos, you have DNS, you have LDAP, etc. Pretty standard. The key piece, I guess, from this slide to take away is all of those policies pieces are being applied locally via sudo, automount, SE/Linux, etc. Unlike on a Windows box, Active Directory isn't enforcing any of those policies over the network. So that's your first pain point, is that actually you might end up in a situation where you think you've got a great password policy, but your password policy is only applying where it's enforced on your Windows systems. It's not being applied to your Unix systems. You think you've got auditing down pat. You think you'll get gathering the right type of telemetry for your network. Well, there's no guarantee that a Linux box is gathering the appropriate telemetry to tell you when someone's poking around. So, attack chains. This is a threat model I put together for Vintella. So this is a slightly more detailed look at the previous slide. Different vendor, different solution, but it's the same problems. So essentially you have a human user, comes in over SSH, comes in over SMB, comes in over whatever Unix authentication service you might have, provides some credentials. Those credentials get passed into PAM. PAM is the authentication module, the set of authentication modules that are used on most modern Unix systems. There will be older systems that don't, but for the large part, assume PAM. PAM talks via a Unix socket to VASD, VASD being the LSAS equivalent, and says, got these credentials, am I okay to let this guy in? VASD can go and talk LDAP and Kerberos to Active Directory to authenticate the user. It can also hit the file system. It can look at configuration files. It can look at a SQL database. And there lies part of the problem. One of the reasons it looks at the SQL database is because of cache credentials. Something we've had on Windows for what? The most of our lifetime, but something that we're gradually dealing with and mitigating the risks thereof. So, I've talked about Vintella. I've mentioned SSSD. Other vendors do exist. As I said, we're talking to 3 or 4 at the moment. I haven't looked at Apple. I'm conscious that's probably a blind spot at this moment in time, but it's one I'd like to have a look at and see what their implementation looks like. kind of hoping that it might be closer to the Windows end of the spectrum than the Linux end of the spectrum in terms of maturity, but yeah, I guess when I look at it, we'll figure that out. So the fundamental truth, and I just said Windows more mature. I'm a Unix guy. Nothing pains me more than to have to say that. I spent the last 20 years working with AIX, Solaris, HPUX, Dynix, Red Hat, pretty much every Unix you can possibly imagine. I'm a Unix guy. But Windows is a whole heap better. Unix is still stuck in the 70s. You know, we're still reliant upon UIDs and GIDs, and that's pretty much the extent of most security boundaries on a Unix box. I know there are some exceptions, but most of the time you find that customers will switch them off because it breaks the applications they need to use. So, by way of a refresher, Windows has restricted admin mode for RDP. It has LSA protection. It has protected users. It has TPM. What does that mean? Well, it means that you can't necessarily authenticate to a Windows domain join system with credentials unless you're in the right group. It means that it's not possible, even if you're privileged, to directly interact with the files that contain the cache credentials or contain the configuration information. It means that in the case of TPM, that the credentials, the key secrets that are used to secure the system are kept outside of the main system in a separate offline chip. And then if you go onto Windows 10, LSAS is virtualized. So LSAS isn't even running in the same virtual machine as the rest of your Windows estate. It is literally sitting there in a isolated container, isolated at a hardware level, and there is a slimmed down set of IPC that allows you to talk to it to do the authentication activities you need to do, but hopefully reduces the attack surface. So, thought experiment. What if I could get into your Unix box and breach your domain? As I've touched upon, Unix systems aren't necessarily quite so well secured. Technical debt is a big problem. If you imagine your typical Unix box, it's probably running something like SAP, or it's probably running something like Oracle. These are systems that don't like downtime, and the business doesn't like downtime because they're the systems that allow you to make your money. So you have technical debt. And of course, what happens then is that you're allowing people to log in over Active Directory. And if we compromise that and we can extract the credentials, then maybe we can use those credentials elsewhere. That can be Windows systems. You know, there's nothing to stop me saying, actually, I've got these credentials from a Unix box, but actually I'm going to go and read your mail. But it can also be other Unix systems. So practical attacks. So I've classed these into 4 distinct areas. There are some attacks that are possible against Red Hat's SSSD implementation. There are some attacks that are possible against Vintella. There are some generic attacks that maybe you guys already know about that affect LDAP and Kerberos. But anyway, let's iterate through them and see what we can do. So, SSD is maintained by Red Hat. It's open source, and potential attacks there look like stealing hashes from the file system, stealing plain text from memory. The credentials live in the process of SSD for longer than is necessary, so you can literally just potentially dump memory and grab the plain text values, and you can mess with the IPC. This becomes more interesting a couple of slides on, but it's worth flagging out now. And from a blue team perspective, it runs as the root. So in principle, you shouldn't be able to get to it unless you're the root user. It does have some SE Linux integration, and it does have some compile time hardening. So it's in the scheme of solutions, perhaps more mature. We'll question that in a second, because it has a bit of a patchy track record. So can you imagine a state of affairs where you could log on to a Windows box, talk to a process, and it give you cached hashes back? Well, SSD at one stage or other had exactly that problem. That wasn't so long ago. That was 2017. I don't think there are any POCs available for these attacks, but I think they're probably something I'd like to work on because, like I say, patching being what patching is, the suspicion I have is that will be SSD in the wild where this vulnerability will exist. So, I've digressed a little. these are the key artifacts. Whether you're blue team or red team, these are the key things to worry about. So you've got your database at the top, you've got your ticket cache, you've got some configuration files, you've got UNIX sockets for the IPC, you've got cached tickets for individual users, and then you've got configuration and the host key tab, etc. Key points from this slide. The only thing that's accessible as a non-privileged user is the thing in bold. Everything else, all of the stuff in italic, you need to be root for, but that's not dissimilar from the situation in Windows in the sense that Mimikatz requires administrative access. So it's like for like in that regard. If you've not got root, there's not a huge amount you can do. Caveat being that, as I said, SSD has Apache record with IPC. The IPC is exposed through those sockets. Contrast SSD with Vintella. It's proprietary, it's multi-platform, has some similar classes of attacks. From a blue team perspective, it runs as a lower privileged user, but it doesn't drop root. So if you've got code execution on it, you can pivot it back up to root, which then potentially puts you in a situation where you can grab the hashes through code execution. It doesn't have compile time hardening, largely I suspect because being multi-platform, the compile time hardening options that are available in AIX or Solaris are quite different from the compile time options that might be available on Linux, and I think they've probably just gone for lowest common denominator. And it has no integration with SE Linux, so there's nothing beyond UID and GID that's protecting that solution. So the artifacts for that look like this. A little bit more interesting. Again, in bold, those are the things you can access as a non-privileged user. So you can access AD POSIX metadata and configuration files. Again, you can't get to the hashes themselves or the tickets without being a privileged user. But as I said, that's not dissimilar from Windows. LDAP, just to reiterate, because I think people are still using that outside of Active Directory per se. Again, you can still hashes, you can take plain text from memory. Man in the middle is an interesting one. How many times have I seen Windows systems that have Active Directory talking over SSL? All of the time. How many times have I seen Unix systems, or systems in general, which are accessible over a web interface via SSL? How many times have I seen them correctly configure LDAP to go over SSL? About 0. And then finally, Kerberos. So even if you don't have LDAP, even if you don't have Active Directory integration, you might still have Kerberos. It's used for things like NFS, etc. So it is out there. So that's the kind of things you can do. What I wanted to do is get to the place where you can do these things, not just pontificate that you can do these things. So I figured I'd go away and write some tools. And the first tool I wrote was Mimikatz. As I've already indicated, you need to be root to have the ability to use it. But I think from an offensive perspective, you can see the value that you go from a position of not having any access to the Active Directory estate potentially to having full access. You have the ability to extract hashes, plain text, tickets. For me, it was worth the investment in time to go and figure out how it works, given that it put me in this position with our customers, with our internal systems, long run. So stealing hashes. If you're running an EDR on a Windows box, the chances are that Mimikatz will be picked up when you drop it on. That's great from a blue team perspective. These attacks can all be performed on Unix using pretty much the standard POSIX command set. So find and CP. I don't know how, as a blue team person, you're expected to spot when somebody's doing that maliciously versus using it legitimately. But it takes a little bit more work to actually use them, predominantly because of the fact that this work hasn't been done before. Now, when I publish the tools at the end of this presentation, it should be dead easy. You should be able to go away, get access to root on a Unix system, and go away and knock yourselves out. But hashes. So I've looked at the hashes that are stored in both Vintella and SSD. SSD uses a stock SHA-512 hash from crypt. So you can literally take your cache database, apply a little bit of pre-processing to get out the SHA-512 hash, and pass it into John the Ripper. And presuming that John the Ripper has an appropriate dictionary, that you've configured the appropriate settings to apply password policy, etc., you should be able to just go away and crack those hashes. It should be that simple. Incidentally, that's the same way that you can attack Samba. If you have Samba on a Unix box, even if it's not Active Directory joined, that's using essentially SSD uses the same storage mechanism as Samba does, so there will be an equivalent file for Samba for local users, and you can go and dump those too. So that's SSD. Vintella, a bit more difficult. For a start, it's a SQLite database. That's easy once you realize it's a SQLite database, but till you do, you're not quite sure what you're looking at. It has its own bespoke hashing algorithms. But the good news is, the Vintella solution, all of the symbols that were there on the binary files, on the libraries, etc. So it wasn't too difficult to reverse engineer. So Vintella has two formats, 3 from the next release, I think is probably fair to say. It has legacy, which I don't think I've actually seen in practice in the wild. It has SHA-256 using a bespoke implementation. The bespoke implementation uses salting with UUID and has some other characteristics. So how hard was it for me to find this information out? Well, from the point where I spotted the function, it was less than a day, probably a couple of hours. And what did it look like? Looked a little bit like that. So essentially, when you log on to a Vintella joined Active Directory system, your password gets concatenated with a hash, your UUID, and another constant, and essentially gets passed into SHA-256, and that gets stored in the cache, and that becomes your future access to the system. I think the reasoning is pretty similar to it on Windows, the idea that perhaps your system might become disconnected from Active Directory for some reason. I can't imagine a situation where that's likely to happen in practice, but that's the rationale behind the caching. So, once you know what it looks like, you can go away and you can write a John the Ripper rule set to process it. This will be up in the Git repo post-talk, so don't bother about scribbling it down now, but essentially it says, we have a hash. It is a SHA-256. It has both a username component, actually that's the UUID, and it has a salt, and combine these things in the following form, so constant 1, UUID, constant 2, plain text value, and then use this as the base for cracking hashes. So that hash is done and dusted. But we can also get the plain text values back. With that, I mean, if you drop the core file for SSD, Vintella, or any of these other solutions, the chances are the plain text values of some people's passwords are likely to still be in the memory of the system. SSD is particularly interesting because the way that it's stored is within a structure. And so there's actually a piece of information that's stored in a structure directly preceding the hash, or the plain text value, I should say, such that you can immediately identify where those plain text values are, rather than Vintella, for example, where essentially you strings the core dump and you have to guess what might be a password versus what might not be. But it's dead easy. And again, from a defense perspective, how many people are really looking at when Gcore, GDB, strings are being run on their systems? I think it's unlikely that that's going to be the case. So that's plain text memory. Then we have tickets. So tickets are the piece of information that means that once you've logged onto a system running Active Directory, you can then log onto other systems without necessarily needing to provide your credentials again. And in the case of both Vintella, SSD, and Kerberos more generally, those tickets from a Unix perspective are stored in /temp. They have permissions that only the issued user should have access to them, but they're there if your root You can go and grab them quite easily. And there are tools plenty to leverage that fact. SMB client is likely to be on a Unix system if it's domain joined. But you could take those cached files, you could run them through Mimikatz on your Windows system. You could load them into Wireshark, so you can look at, for example, the encrypted traffic between the Unix system and the domain controller. It means you therefore have got the ability to start compromising that. And allegedly, you can also load them into X3RDP. I've not had that working, and I'm a little bit skeptical because I don't think it should work, but there is documentation that indicates that it might. Open source documentation is always somewhat untrustworthy. Right. Tickets. That's how easy it is to misuse somebody's ticket. So on the left-hand side from your perspective, you have an administrator. They have a ticket, they have a TGT, a ticket granting ticket, for the thirdparty.example.org domain. And on the right-hand side, I'm copying that ticket to another file. That's the bit where you need to be root. I then log into a separate account again, the user account. I set the appropriate environment variable to point at my copied ticket. And now I'm administrator. Really is that simple. So Mimikatz gets us a few things. It gets us the ability to grab cached hashes. It gives us the ability to scrape process memory. It will allow us to locate quickly and efficiently Kerberos tickets, and it will grab appropriate Active Directory metadata where available. However, that's not the end of the release. So, I wanted to make this as easy as possible for both sides. So we have post-exploitation modules for Metasploit. We have the John the Ripper rule set to allow you to go after Vintella hashes and crack them quite happily. We have audit D policies, so that there's a chance if you're the blue team, if you load these policies into your Unix estate, you might actually spot the bad guys doing stuff. And eventually, I want to share everything I've been doing, all my research, all my fuzzers, etc. I think nothing bugs me more than cases where people give a great talk about an awesome bug, and then don't share anything, and nobody really learns a huge amount afterwards. So I'm going to be sharing everything I possibly can do. So it's not up yet, but that's where you'll be able to find it. And as I said, it's there to enable both the blue and the red team. I don't want to be one of these guys that's playing for one side. I like to see both sides improve. So that's what the structure looks like. As I said, there's John the Ripper, Metasploit, Audit D. The data and the tools bit will probably be quite interesting if anybody wants to take this research on and take it further, because I think there's probably enough room for another 12 months of research with some of the aspects I've been looking at. Anyway, that's the bad news. That's how we can breach an Active Directory estate from a Unix perspective. But no good talk is complete without a discussion about how you actually protect yourself, the mitigations, both the mitigations from an operator perspective. You know, you're the guy that's responsible for the Unix estate. What do I do? But also from the developer's perspective, I'm writing software to do this kind of thing. How could I write it better next time so that this kind of thing is less easy to do? So from a mitigations perspective, so this is the things for the operators. Generic hardening, restricting root access, always a nice thing to do. I think it's rare that we find boxes that are as well secured as we'd like them to be. It's not the focus of this talk, but I think there's more work to be done there. SE Linux, it's a fucking arse to switch on. It's an arse to get running, but we really need to take the time to get it working, to get it used on Unix infrastructures. Reading the man pages is a super useful thing. So, generic hardening. The cached hash feature on a Unix box is on by default. Really ought not to be. There is no good reason why a Unix box is ever going to find itself in a situation where it can't talk to the domain controller. Hardly likely you're going to take your Unix box home at the weekend and plug it in on your home network to get a little bit of extra work done. So turning it off will be a super useful first step. We as attackers, if we're working for organizations, should be pointing this out to the organizations we're working for. we should be identifying when we've got an Active Directory joined Unix system in the scope of an assessment, and we should be flagging it out so that the organizations can have a bit of a think about it. If only it were that simple, we should be patching our systems better. Yeah, there are systems that I've seen that haven't been patched in 2 or 3 years. That's unacceptable. And it's only a matter of time, if that's the case for an organization, before somebody bad will do something bad to your systems. And we should be looking for privilege escalation attacks. In many cases, there are dumb and easy ways to get root on large enterprise networks. Really, we ought to be doing a better job of getting rid of those. So specifics. Restricting access to ptrace is a super useful thing to do from a generic perspective, but in this particular instance, any of the attacks that look at the cached memory, so the plain text or the hashes in memory, is only possible because we can use GDB. Disabling the ptrace capability using YAML or SE Linux, I'd suggest should be done. At the very least, you should have some monitoring in place so you know when it's being used and by whom. Protecting resources with SE Linux. Interestingly, both Vintella and SSSD have SE Linux policies. In Vintella's case, it's in a GitHub repo, which isn't clearly flagged out to anybody that's deploying it. It's somewhere on the internet. In fairness, it's in one identity who own Vintella's organizational project group, but you're unlikely to find it by accident, shall we say. So I guess if you're deploying Vintella, go away and grab those SE Linux policies and apply them. Auditing. So most of what I've talked about so far in terms of mitigations has been around how you protect yourself before you get the breach. Auditing is a must from a prepare yourself for when you do get breached. Most people on Unix systems appear to rely upon logging. Logging and auditing have slightly different roles and responsibilities. Logging is for developers. Auditing is for sysadmins. It's noticeable in the case of Vintella that auditing is for developers, because if you switch the debug level up high enough, you get full packet captures of all of the IPC that's happening, which is super helpful when you're writing fuzzers. But I don't really think most administrators are going to want that information. They're probably going to want to know when I'm touching the socket, when I'm touching the cached hashes, when I'm reading the configuration files, etc. So the manual, super useful place to look. It's in there, in plain sight. There is an option to control the cached hashes. There is an option to determine what encryption level is applied to Kerberos tickets. It's all there, just nobody's looking at it. So this is an interesting one. Kerberos is enabled as part of Vintella and as part of SSSD. In many cases, it probably doesn't need to be enabled at all. There's no reason necessarily to grant tickets, because most of the time when you connect to a Unix box, you're on that Unix box. You're unlikely to start RDPing through a Unix system. You're unlikely, unless there's a particular reason, to use SMB to map back to other parts of the network. So actually, you could probably switch off the Kerberos bit entirely, which means that if someone breaches your Unix system, they can't take your identity and misuse it anywhere else. Well, they can take the hashes, but they can't take the Kerberos tickets and use them. So go have a look. So that's an operator's view of the kinds of things you need to be doing. In terms of vendors, because I think vendors had a little bit of a hard time digesting some of this. Harden your binaries. As I said, I've been fuzzing Vintella and had some success. It's going to be easier to exploit because they aren't hardened, because there isn't any ASLR, because there isn't any additional checking around stack usage. Permissions, drop unnecessary privileges. Parts of SSD, Vintella necessarily need to run as root. Other parts probably don't. Parts of the artifacts need to be accessible by normal users. Parts of it don't. You know, that metadata is a great example. I don't know that there's a case for a user directly be able to access that AD metadata, despite the fact that it's there in a SQLite database and anybody can go and have a look at it. Yeah, covered that, I think. So cryptography. One of the problems with the solutions that we've looked at so far is that the hashes aren't stored particularly well. And actually, Vintella, one identity, have been super useful in terms of working to resolve that. But realistically, we shouldn't be storing passwords as hashes these days. If ever, it's perhaps a caveat to that statement, but you know, there's enough good work being done on storing passwords in appropriate fashions. Please stop using hashes. So I've mentioned the Vintella were pretty fucking awesome. And that's just how awesome they were. So when we started speaking to them back in June, their first thought was, actually, can we give you our SDK so you can make your fuzzing more effective? Their second thought was, great, we'll get rid of the SHA hashes, we'll move across to bcrypt. Their third thought was, oh, yes, plain text in memory. Yeah, we know why that is. It's because we have to keep it there in case somebody needs a password reset as part of the login process, and we don't want to ask them for their password again. But we'll write a separate cleanup thread that will clear down that memory as quickly as possible. And they put in with their SAP Linux policies. It's really nice and refreshing to work with a vendor that was responsive. I wish all vendors were like that. But in fairness to all of the other vendors we've been talking to around this Active Directory research, they've all been pretty good. Red Hat been pretty happy to talk to us, and some of the other vendors who've had somewhat shorter timelines. I think there's a vendor I started talking to last week. They've been good too. The takeaway shouldn't be that the vendors are doing this because they're lazy, because they're incapable. They're doing it because nobody, i.e. their customers, is asking for them to be more secure. So some conclusions. A little bit on what we've learned, some next steps, because there will be more work that I'm publishing in due course, and then some thanks. So, what have we learned? Active Directory on Unix is just the same as Active Directory on Windows. In fact, it's just the same as Active Directory on Windows around the era of XP. Hashes, passwords, not well protected. Trust relationships are there to be exploited. And quite frankly, read the manual. So my next steps. So if you want to keep an eye out for what I'm going to be doing next with this, the Vintella IPC implementation, I would like to get a better handle on all of the functionality that has, because it seems to have quite a lot. I'd love some POCs for some of the SSD things. If I can get them myself, I will, and I will be making them available, hopefully with some IOCs to help the blue teams pick them on their networks. Continuing to work with the vendors. I went into this project thinking it'd be a couple of weeks worth of work. It strikes me that there's plenty more to be done. Meterpreter, Metasploit. I wrote some pretty crude post-exploitation modules to suit my purpose. The Unix part of Meterpreter needs love. There are so many awesome things that you can do with Unix that aren't being done because the functionality doesn't exist. I know Unix isn't as sexy as Windows and OS X, but if you've got time, you've got interest, I'm sure the Metasploit guys would appreciate contributions in that regards. So that's just about me done. Apart from this, I think it's always important to acknowledge your peers, the people that have helped you along the way. So in terms of active help, Cisco's internal security organization would be wonderful. Solar Designer, who's the guy that writes John the Ripper, or maintains John the Ripper, has been great in terms of helping with some of the esoteric flags that are necessary to get the hashes to crack, and then borrowed ideas. This isn't everybody that's ever worked on Active Directory, but it's a good starting point. You should be going and following these guys, reading what they have to say, and hopefully learning from the work they're doing. And then special thanks, the vendors, who, as I say, have been awesome. I've never had a situation where vendors come back to me and essentially said, we'll give you internal source code to help you attack this faster. So that's pretty cool. And we are done. So are there any questions?
Hello. One of the most important part of Mimikatz and getting the hashes from the system is lateral movement through past the hash attacks. Since what you're saying is that all implementations use custom, under quotes, hashing mechanisms, are those kind of lateral movement attacks possible at all?
So that's a great question. So the question was, in case anyone didn't hear, was are the hashes in a format that you can use for pass the hash? Right, no, that's the bad news. It's the thing that made me sad, or made me happy, depending on how you look at it. You can't take those hashes and use them for pass the hash because they're stored in that custom format. So that's probably the one saving grace. But yeah, I did think about that. Would have been nice.
Hi, I was wondering if you ever looked into the swap file system of Linux, because there's also many information within the swap file system, like credentials, plain text, etc.
Absolutely, great question. So yeah, the swap undoubtedly has more of these secrets. I guess the key piece is probably figuring out how to identify what's useful versus not. You think about a multi-gigabyte server. Swap is going to have quite a lot of information in it, not necessarily a huge amount of useful information, or for varying values of useful. You could certainly go looking for the SSD plain text values. I think Vintella, you would struggle. I think probably, if I were being entirely honest, the best thing to do would probably be to figure out how Vintella and SSD are actually storing the data in memory. Because the better the understanding you have of how they lay their memory out, the better chance you have of retrieving. Cool.
So just a curiosity, on your slide, you on the SSD private circuit, there was Herbie Dragons, and then on the security evaluation, there was a missing dot. So is there something you discovered on that socket, or?
All omissions are intentional. Actually, the fuzzers are actually in the Git repo already, and one identity have already got access to that information. The truth be told, I haven't finished the triage of those bugs, and indeed, because I only started that in the last month or so, it to be continued. I've not found anything yet which is a smoking gun, but the very fact that the UNIX socket is accessible to everyone was a red flag in my mind when I started, and I haven't done enough to prove that it's not a red flag now, but I haven't done enough to prove that it is either, if that makes sense.
Okay. Thank you.
All good? Perfect.